How to Lie with Statistics by Darrell Huff. Picture this. It's a few years after Yale's celebrated class of 1924 tossed their caps in the air. A shiny report lands on desks across the country, claiming that the average graduate from that class is raking in $25,111 a year. Back in those days, that was the kind of money that made parents start measuring their kids for Yale sweatshirts before they could even walk. But wait, something smells fishy here. $25,111? Really? Down to the very last dollar? How on earth could anyone track down the precise income of thousands of scattered graduates, with all their quirky side hustles and mysterious investment portfolios? Most of us can barely calculate our own yearly earnings without a minor existential crisis. And right there the curtain lifts on the greatest show on earth. A number, dressed up in a fancy suit of scientific precision, struts onto the stage. It looks so official, so trustworthy. After all, numbers don't lie, right? Well, here's the uncomfortable truth. They absolutely do. Numbers can be twisted, spun, and contorted to whisper whatever story their handler wants you to hear. Back in 1954, a sharp-eyed journalist named Darrell Huff decided he'd had enough of this nonsense. He wrote a deceptively thin book called How to Lie with Statistics, and it's aged like fine wine. This isn't some dusty textbook that'll put you to sleep. Think of it as a cheat code for modern life, a secret decoder ring for navigating a world drowning in charts, graphs, and numbers, screaming at you from every screen. Huff wasn't some ivory tower mathematician. He was a journalist who understood how words and numbers could dance together to seduce your brain and occasionally to rob you blind. He wrote this book as a kind of self-defense manual. The con artists, the slick advertisers, the smooth-talking politicians, they already knew these tricks inside out. Huff wanted honest people to learn them too, not to become tricksters themselves, but simply to stop being suckers. And here's the thing, his warning is even more vital now than it was 70 years ago. Statistics rain down on us constantly, from our phones, our news feeds, from people desperately trying to sell us everything from vitamins to political candidates. So here's my promise. Stick with me, and by the end of this journey, you'll have developed a kind of X-ray vision. You'll be able to peek behind any statistic, poll, or fancy graph and spot the puppet strings. You'll speak the secret language of data manipulation, and you'll become almost impossible to fool. This isn't just about protecting yourself from bad math. It's about learning to think clearly when everyone around you is trying to cloud your judgment. Ready? Let's dive in. Here's the foundational secret that changes everything. Nearly every statistic you've ever encountered comes from something called a sample. If you want absolute certainty about how many red and white beans are swimming around in a massive barrel, there's only one guaranteed method: count every single bean. But who has that kind of time? So we compromise. We reach in, grab a handful, and cross our fingers that our handful mirrors the whole barrel. That little handful? That's your sample. When chosen carefully, it can reveal astonishing truths about the entire barrel with remarkable accuracy. But when chosen carelessly, well, that's where the lies start multiplying. Huff calls this the sample with the built-in bias. And it's the original sin of dodgy statistics. Here's a thought experiment. Imagine a newspaper wants to prove its readers are intellectual heavyweights compared to regular folks. A serious polling organization like Gallup would invest serious money and effort to carefully select a proper cross-section of society. They might discover that about a third of people have never even heard of the metric system. But our newspaper takes a shortcut. They print a little coupon and ask readers to clip it out and mail it back. When the results arrive, they proudly trumpet that 98% of their readers are metric system experts. See what happened there? Who actually bothers to cut out a coupon, fill it out, find a stamp, and mail it in? Only the people who already know and care about the topic. Everyone else tossed that newspaper in the recycling without a second thought. This is a self-selected sample, and it's about as reliable as a chocolate teapot. It doesn't reflect the newspaper's readers. It reflects the tiny, motivated slice of readers who chose to participate. Now let's circle back to that suspiciously precise Yale salary. How did they conjure up $25,111? They sent out surveys to graduates. But who actually responds to income surveys decades after graduation? First problem, finding people. The university lost track of many alumni over the years. Who are these missing graduates? The successful ones? Unlikely. Successful people are easy to find in directories like Who's Who. The missing ones are probably the folks who didn't set the world on fire. The struggling artists, the retail clerks, the people whose careers didn't quite match their youthful dreams. This entire group, which would drag the average down, never made it into the sample. Second problem, among those they did find, who bothers filling out the form? The people proud of their paychecks. The person embarrassed by their modest income is far more likely to accidentally lose that questionnaire in the trash. So the final sample consists entirely of successful graduates who could be tracked down and who were eager to brag about their earnings. That $25,000 figure doesn't represent the typical Yale graduate. It represents the cream of the crop, who wanted everyone to know they were the cream of the crop. The sample was hopelessly biased from the start. This same bias lurks everywhere. A psychiatrist might announce that everyone is neurotic, but his entire sample consists of his patients, people who showed up precisely because they were struggling. You always have to ask, who did they actually talk to? If the sample is rotten, the conclusion is worthless, regardless of how scientific it sounds. The most spectacular example of this was the Literary Digest poll in 1936. They surveyed millions of people and confidently predicted that Landon would crush Roosevelt in the presidential election. They were hilariously, catastrophically wrong. Why? Because they pulled their sample from telephone directories and magazine subscription lists. In 1936, during the depths of the Great Depression, people who could afford phones and magazines were considerably wealthier than average voters, and they leaned heavily Republican. The sample was economically skewed, and it predicted an election result that never came close to reality. So your first question, when confronted with any statistic, should always be, where did this data actually come from? Was the sample truly random, or was it biased from the very beginning? Because if the foundation is cracked, the entire structure is doomed. But let's say someone has a perfectly good, genuinely unbiased sample. They can still bamboozle you beautifully. One of the most elegant tricks is hiding behind the word average. Imagine I'm a real estate agent trying to sell you a house in a new development. I lean in with a knowing smile and whisper, "You're going to love this neighborhood. The average income here is about £10,000 a year." You're impressed and you sign on the dotted line. A year later, I'm back, this time collecting signatures to fight a tax increase. I hand you a petition and say earnestly, "We have to stop this. After all, the average income in this neighborhood is only £2,000 a year." Did I lie to you? Technically, no. Both figures can be perfectly legitimate, mathematically correct averages calculated from identical data. The trick is that average is a slippery little word that can mean three completely different things: the mean, the median, or the mode. That impressive £10,000 figure was the mean. This is what most people think of as average. You add up everyone's income and divide by the number of people. The problem is that outliers can yank the mean around like a puppet. Most of your neighbors are modest farmers and retirees, but 3 millionaires live up on the hill. Their massive fortunes drag the mean way up, creating a number far higher than what almost anyone in the neighborhood actually earns. It's entirely possible for nearly everyone to be below average. That smaller £2,000 figure was the median. The median is the person standing in the middle. Line everyone up by income, and the median is whatever the person in the center position makes. Half earn more, half earn less. It's a much better snapshot of the typical person's reality and isn't distorted by those millionaires on the hill. Then there's the mode, which is simply the most common number. If more families earn £3,000 than any other specific amount, that's your modal income. So when a company boasts that its average employee salary is $75,000, you need to ask, which average? If it's the mean, that number might be artificially inflated by the CEO's multi-million-dollar package, while most workers make far less. If it's the median, you know half the employees make more and half make less, which tells a much more honest story. Whenever someone throws around the word average, without specifying which type, they're probably choosing whichever version makes their case look best, and your skepticism alarm should start ringing. But the deception doesn't stop there. Some of the sneakiest statistics are defined by what they're hiding. Huff calls these the little figures that are not there. You've seen the toothpaste commercial. Users report 23% fewer cavities with Sparkle Bright. There's even a certificate from an independent laboratory. Sounds bulletproof. But if you dig through the microscopic fine print, you might discover the test group consisted of exactly 12 people. With such a tiny sample, random chance can create almost any result imaginable. Flip a coin a dozen times, and you might get 8 heads, but that doesn't prove the coin is rigged. It's just luck. The Sparkle Bright company could run a dozen of these small tests. 10 might show no effect, or even worse results. But by sheer probability, one test is likely to show dramatic improvement. So what do? They quietly bury the 10 disappointing results and trumpet the one success story from every billboard. They're not technically lying about that one test. They're just conveniently forgetting to mention all the others. Another critical missing piece is the measure of reliability or probable error. This is especially important with something like IQ tests. Say one child, Peter, scores 98 on an IQ test, while another child, Linda, scores 101. Easy conclusion. Linda is smarter, right? Not so fast. Any decent IQ test comes with a probable error. The Stanford Binet test, for instance, has a probable error of around 3%. This means Peter's true score likely falls somewhere between 95 and 101, while Linda's probably sits between 98 and 104. These ranges overlap significantly. Peter might actually have a higher true IQ than Linda. That tiny 3-point difference is statistically meaningless noise. But because that crucial plus or minus figure gets left out, people make all sorts of confident judgments that are complete nonsense. A difference only matters when it actually makes a difference. This leads us to one of the most powerful weapons in the statistical liar's arsenal: visual deception. The human eye is powerful, but embarrassingly easy to trick. A cleverly designed graph can transform a tiny, insignificant change into what looks like a world-shaking catastrophe. Huff calls this the gee whiz graph. Let's say a country's national income rose by 10% over a year. If you draw an honest graph with the vertical axis starting at 0, you'll see a pleasant, modest upward slope. It's nice, but hardly thrilling. But what if you want to manufacture some drama? Simple surgery. Chop off the bottom of the graph. Instead of starting at 0, start your axis just below the lowest data point. Now that same 10% increase that once occupied a small portion of the graph suddenly rockets from the bottom of the page to the very top. The visual impression screams explosive, monumental boom. You haven't altered a single number, but you've completely transformed the story the data tells, just by manipulating the frame. You can amplify this even further by stretching the vertical axis. Make each tick mark represent smaller and smaller values. Now your line climbs at an even steeper, more heart-stopping angle. This happens constantly in corporate reports and news magazines to make modest gains look enormous, or small declines look apocalyptic. Another visual trick is the one-dimensional picture. Say the average weekly wage in country A is £15, and in country B it's £30. You could illustrate this with 2 money bags. The honest approach would be showing 2 bags for country B and 1 for country A. But that's not dramatic enough. So instead you draw 1 money bag for country A, and for country B, you draw a money bag that's twice as tall. Here's the problem. When you make it twice as tall, you naturally make it twice as wide to keep it looking like a proper money bag. Suddenly, the second bag occupies 4 times the area on the page. And since our brains perceive money bags as 3-dimensional objects, we subconsciously assume it's twice as thick too. The volume of the second bag now appears 8 times larger than the first. The numbers say 2 to 1, but your eyes are screaming 8 to 1. You've used a picture to plant a wildly exaggerated impression in the viewer's mind, and it's almost impossible to consciously resist. Finally, we arrive at the most subtle forms of deception, the ones hiding not in the numbers or pictures, but in the logical connections between them. The first is the semi-attached figure, where you prove one thing and then casually pretend it means something else entirely. The classic example is the mouthwash that, quote, killed 31,108 germs in a test tube in 11 seconds. The statement is absolutely true. The laboratory report is genuine. But what does this have to do with curing your cold? Practically nothing. A chemical that slaughters germs in a glass tube under perfect laboratory conditions might be completely useless in your actual throat, especially after it's been diluted with saliva and mixed with food. And who says those particular germs were even responsible for your cold? The statistic is impressive, but it's attached to a conclusion it simply doesn't support. You see this constantly in safety statistics too. More people are killed in airplane accidents today than in 1910. This is true, but does it mean flying is more dangerous? Obviously not. It just means millions more people are flying now. The raw number of accidents is a semi-attached figure. The relevant number is the accident rate per million passenger miles, which tells a completely different story. This brings us to the granddaddy of all logical fallacies, what Huff calls post hoc rides again. The full Latin phrase is post hoc, ergo propter hoc, meaning after this, therefore because of this. This is the mistake of assuming that if 2 things happen together, one must have caused the other. Someone once studied college students and found that smokers got lower grades than non-smokers. The obvious conclusion everyone jumped to: smoking makes you dumber. But is that the only possible explanation? Couldn't it work the other way around? Getting bad grades is stressful, driving students to smoke for relief. Or, far more likely, couldn't some third factor be responsible for both? Perhaps the kind of student who is more social, more rebellious, and less obsessed with academics is also more likely to pick up smoking. The correlation is real, but the conclusion about cause and effect is completely unproven. You can discover these spurious correlations everywhere if you look hard enough. There's an actual statistical correlation between Presbyterian ministers, salaries in Massachusetts, and the price of rum in Havana. Does one cause the other? Of course not. Both are influenced by a third factor: general worldwide inflation over time. This fallacy gets used constantly to prove that college education causes higher income. It's true that college graduates typically earn more, but they don't necessarily earn more because they attended college. Universities tend to attract 2 groups disproportionately: very bright people and very wealthy people. Bright people might have earned more anyway thanks to their intelligence, and wealthy people have connections and family resources that give them advantages regardless of their degree. The college diploma might just be a symptom of pre-existing advantages, not the magical cause of future success. The world of statistics is an absolute minefield of these logical traps, and recognizing this fact is your first step toward genuine intellectual freedom. You start to understand that a number, no matter how authoritative and official it appears, is only the beginning of the conversation, never the end. When Darrell Huff penned this book in 1954, he was battling against slick newspaper advertisements and manipulative corporate reports. He couldn't have possibly imagined a world where we all carry supercomputers in our pockets, where social media turns each of us into both consumers and publishers of statistics. A world where a misleading chart can be created in 30 seconds and shared with millions in 30 more. And yet, the simplicity and timelessness of his warnings make this book more vital today than ever before. Bill Gates himself called it more relevant than ever, and it's hard to argue with a man who knows a thing or two about data. We're swimming, sometimes drowning, in an endless ocean of data, constantly told that, quote, the data doesn't lie. But Huff teaches us something far more profound. Data never speaks for itself. It's always presented by someone with a perspective, an agenda, a product to sell, or an argument to win. The numbers themselves might be technically accurate, but the story they're woven into can be pure fiction. The real gift of this book isn't turning you into a cynical person who distrusts everything and everyone. It's transforming you into a discerning person who questions things intelligently. It hands you a practical toolkit for clear thinking, a set of straightforward questions you can apply to any statistic you encounter, whether it's in a breaking news story, a politician's speech, or a viral post from your favorite influencer. Huff outlines these questions in his final chapter, and they're worth memorizing. They're your intellectual armor. First, who says so? Look for potential bias. Is the source trying to sell you something? Is there a hidden agenda lurking beneath the surface? Is a respectable institution like a university being name-dropped to endorse a conclusion they never actually made? Second, how do they know? Examine the sample carefully. Was it large enough to matter? Was it truly representative? Or was it biased from birth? An astonishing amount of confident-sounding nonsense is built on the shaky foundation of a terrible sample. Third, what's missing? Are they revealing the sample size or the margin of error? Are they specifying which type of average they used? Often the most deceptive element of a statistic is the crucial context that has been strategically omitted. Fourth, did somebody change the subject? Are they reporting laboratory germ counts and implying it'll cure your cold? Are they using a shocking raw number when the more meaningful rate would tell a completely different story? And finally, the most powerful defense of all, does it make sense? This is your ultimate weapon. So much of what masquerades as statistical fact crumbles instantly under the weight of simple common sense. When someone claims life expectancy is 63, so retirement at 65 is some kind of scam, does that match the reality you see around you, full of healthy people in their 70s and 80s? No. And that simple reality check is often all you need to spot the lie. Learning to apply these 5 questions is like developing a genuine superpower. It allows you to navigate the world with greater clarity and less fear. It's the very heart of critical thinking, a skill that isn't just useful for homework, but for every major decision you'll face for the rest of your life. That was a summary of How to Lie with Statistics by Darrell Huff. We've definitely covered the major tricks and traps today, but here's the honest truth. A summary can only ever be a rough map. The real treasure reveals itself when you explore the actual territory. The true magic happens when you read the book itself, and some particular story or simple phrase from Huff suddenly clicks in your mind in an unexpected way. This summary is meant to be your starting point, helping you decide if this journey calls to you. If anything we've discussed today has sparked your curiosity or shifted how you see the world even slightly, then I genuinely encourage you to grab a copy. Reading it isn't just about learning facts. It's an experience that can authentically sharpen the way you think for a lifetime. Also, if you found this summary valuable, I'd be incredibly grateful if you'd hit that like button and subscribe to the channel. That way, you won't miss our next exploration into another transformative book from the billionaire's bookshelf. Let's keep learning and growing together.